Hello friends, welcome back, and in this video we are going to discuss about the CountVectorizer. In the previous video we have discussed about the TF-IDF vectorizer. So for the TF-IDF vectorizer, you know that we need to import this particular package sklearn.featureextraction.text import TF-IDF vectorizer, which is a class basically. So we have seen about the TF-IDF vectorizer, how it works, and in this video we are going to see about the CountVectorizer. This is again from the same package sklearn, and we have to import this particular class CountVectorizer. So here you might have seen that we have used this CountVectorizer to create its object, and creating its object we have passed the training count or the training data to the specific to the CountVectorizer. I mean whatever CountVectorizer has splitted, how it has maintained your training data. With that data, we have trained our model, right? So we will discuss about this one as well. What is this multinomial NB? So we have created an object of multinomial NB, and after that we have passed this X train count and Y train, which is basically from the CountVectorizer only. So let's see what we understand about the CountVectorizer. So it is here. So in the CountVectorizer, how it fits? Let us see how it fits. The vectorizer, I mean this object vectorizer reads the training data, whatever data you pass, and then builds a vocabulary of unique words. Obviously, unique words need to be fetched out, and this stores the vocabulary in the vocabulary underscore. This is the name of the attribute. So under this attribute, it stores the set of unique words, which is the vocabulary. Now, how does it does the transformation? How does it do? So first of all, the vectorizer tokenizes the input data into words. So basically, whatever input data you have got, you will tokenize it into the word. So if you have to tokenize some input into the word, then you will obviously find out these spaces. The spaces will split your text into the different words, right? So most probably around the spaces, these words are splitted. For each word, it counts the occurrences in each document. For each of the word, it counts the occurrences in each document. So you will see in the example, and the resulting count are arranged in a matrix where rows represent document, columns represent words in the vocabulary, and values are the word counts. So we will see that what does it mean with the help of an example. The fit transform method returns this count matrix, which can be used as input to machine learning algorithm. So basically, fit transform does the required transformation, which gives you a model basically, using which you can use it to predict anything which is related to this this sentiment or whatever word processing you are doing, right? So here we have taken one example. There are two differences with the TF-IDF vectorizer as well. Before that, we will discuss this one before the example. So there are two differences. So CountVectorizer doesn't calculates IDF weights on TF-IDF scores. I hope you might have gone through my previous video where we have discussed about the TF and IDF scores. So unlike the TF-IDF vectorizer, the CountVectorizer doesn't care about the IDF weights, and it simply counts the occurrences of each word in each document. All right, so these are the two differences. So if someone asks you the differences, basically this can be asked. If you are working on the Python libraries for the machine learning, then in any interview, this question can be asked. Like, what is the difference between the TF-IDF vectorizer and the CountVectorizer? Okay, so here we have example now. How does CountVectorizer works? So we have again the same example. In the document one, we have this thing like the quick brown fox. This was the sentence. And in the document 2, we have this sentence, the lazy dog. So what it will do? So first of all, it will fit the vocabulary. It will first create the vocabulary, and the vocabulary will be of the unique words. So what are the unique words here? The quick brown fox from the first document, and then the lazy dog, because the is already there and this we have already counted. So the lazy dog, only lazy dog will be here from the second document. So to fit the vocabulary, we create a list of vocabulary basically from all the documents. After reading all the documents, it will create a vocabulary of all the unique words. And after that, it will transform the document into the count matrix. How does it do? So you can see in the document one, right? In the document one, you can see that quick brown fox. These are the 4 words which are available in document one. So for the document one, we will take this vocabulary, right? This one. And wherever that word is available, which is available in document one, we will make it one. Like the is available in the document one, the quick is available in the document one, brown is available in the document one, fox is available in the document one. But if we talk about the lazy and dog, these are not available, so we make them 0 and 0. Okay. So this is how document 1 has been created. The matrix has been created. So first row contains the document, and along with the document, it contains the words which are there. So it marks with them with the digit 1, whatever whatever words are available in the document 1. Now we come to document 2. In the document 2, you can see the is available, so you will make it 1, right? First position is for the in the vocabulary, so we will make it 1. After that, we have quick brown fox, which is not available in the document 2. So the quick will be 0, brown will be 0, the fox will be 0. Now we come to lazy and dog. Since the lazy and the dog both are available here, so we will make them 1 and 1 in the document 2. Okay, so if you see, this resultant matrix is of shape 2 cross 6, right? Why 2? Because we have 2 documents. If we had 3 documents, then it could be 3 into the number of unique words, right? So number of unique words are 6, and the number of documents are 2, so it will be of shape 2 and 6. And each row represents a document, and each column represents a word in the vocabulary. The values are the word counts. Whatever values you have given, they correspond to whether the word is available in the document or not. Okay, so you can make a note here as well that CountVectorizer can also be configured to use binary counts, whether something is present or absent or not, instead of frequency counts by setting the binary parameter to true. So here we have done like 1, 1, 1, right? But if it comes twice, like quick, brown, fox, lazy dog, if the quick was twice in the document 1, then it could have been value 2. But here it's only 1. So it's not like you will make every word 1. It is the count, right? It is the count only. Since we have only once available this quick word here, so that is why it's 1. If there was another, quick word here, then in that case, what will happen? Here it will be like quick will be 2. So it is basically the count. But here there is another note given here that you can configure the CountVectorizer to use the binary counts, whether something is present or absent in a particular document or not, instead of frequency counts. Okay, now since we have understood about the TF-IDF and this CountVectorizer both, so we have to understand that what is better among these two. Which one is better among these two? Okay, so I have these notes here, so I will just read it out for you. So both TF-IDF vectorizer and CountVectorizer have their strengths and weaknesses, right? The choice between them depends on the specific problem, data set, and goal. And when you will use it, here is a brief description. When you will use the CountVectorizer, right? What are the pros of using the CountVectorizer? It's very simple and fast, right? Counts word occurrences, making it computationally efficient. Good for small data sets. So CountVectorizer is really good for the small data sets and not for the big data sets. So this is the pros for the CountVectorizer. It is good for the small data sets, which is suitable for small to medium sized data sets where word frequencies are important, right? Word frequency of the word is really important. Different words have different frequencies in the document, so that is important. Okay, and what are the cons? Cons is like it doesn't evaluate the importance of the word. Here you can see it only counts like how many times a particular word occurred in a particular document, but it is not going to understand the significance, or it is not going to calculate the significance of a document, sorry, a particular word. So it ignores the word's importance. It treats all words equally without considering their significance in the context. Okay, it treats all the words equally. For it, like for CountVectorizer, there is no difference between one word and other word, because For it, there is no significance level set. It just counts the word. But in fact, when we are talking about the sentiment analysis, do you think that only the count of the word is important, or the significance of the word is also important? I hope you understand that it's also the significance of the word which is also important when you are doing the document analysis, or you are doing some kind of analysis where you are finding where you are trying to find out the central theme of the document, or you can find out the crux of the document around which this document has been created. So obviously, for the count vectorizer, you cannot associate any word importance, so it's not really useful, that much useful for the big data sets, and that too when you are uh, going to do some kind of sentiment analysis kind of model you are going to prepare. Okay, now come to the TF-IDF vectorizer. What are the pros? Pros are like capture word importance. This is the very first pros. This is the good thing about it. It uses TF-IDF scores to weight word frequencies by their importance in the context. And it's like robust to noise. Noise means unnecessary words, irrelevant words. So it reduces the impact of irrelevant words or stop words. So, but in case of count vectorizer, can you see this thing? Robust to noise, which is really important when you are doing the, sentiment analysis. So your model need to be robust to noise if you are preparing a model which is related to the sentiment analysis. Now come to the cons. So more computationally expensive. Obviously, it calculates the TF-IDF score. So it's obviously a bit slow, but it gives you better results. So if you are going to use it for the sentiment analysis, then you have the good choice. So it is slower than the CountVectorizer. So this is also an important question. It could be an interview question. Which one is really fast and efficient in terms of calculation, in terms of correctness, and in terms of giving you the most accurate results? It's like TF-IDF score, or you can say like TF-IDF vectorizer when you are talking about the sentiment analysis. But when you are talking about the uh, you know computational speed, then in that case CountVectorizer is far much superior, right? The other one is may overemphasize rare words. Yeah, this can give too much importance to rare words, because rare words will have less importance, and but still they will have the high IDF, right? So it may potentially lead to overfitting, right? So when to use each? When you should use the CountVectorizer, there are some tips for it. So CountVectorizer you need to use when there is a small to medium sized data set, and word frequencies are crucial, like in case of text classification or in case of topic modeling. So if these are the two things you are going to do with the help of your model, then in that case you can use the CountVectorizer. And wherever the computational efficiency is essential, okay, wherever you want, like I should do the computation really fast, then in that case computational efficiency is really essential. Then in that case CountVectorizer you can use. What is TF-IDF vectorizer? So when should use when we should use TF-IDF vectorizer? So on the large data sets or high dimensional text data, where the word importance is really crucial, and you want to reduce the impact of noise and irrelevant words. So if you have to reduce the noise, then in that case TF-IDF vectorizer can be used. So where the words are important, just like here you can see like information retrieval and the sentiment analysis. It has given this example. So basically the TF-IDF vectorizer is really useful when you are going to do information retrieval or the sentiment analysis, these kind of projects. If you are going to create, then in that case TF-IDF vectorizer is useful. Okay, here you can see this, like I have written this, and most probably I will just copy paste this for you, because I'm just going to write read it out for you. But whatever I have to make it clear to you, I have already done. So this one you can read. So I will just put it in the description section. So I hope you might have enjoyed it. And if you have enjoyed it, just like my video and subscribe my channel and share my videos with your friends. Have a nice day and bye-bye.